So once again, welcome to the videos for Shaughnessy's class, Math 30-2. This is Probability and Set Theory Lesson 5. It's all talking about odds. Now if I look at odds, odds are, kind of like probability. They are related, but they are a little different. And so hopefully this is clear. Now the first thing I want to say is the following two large statements. Okay, odds is not the same as probability. They are not. They are not the same as probability. And you'll understand that in a few minutes. The odds when gambling, though, are not the same as odds for probability. They just are not. Gambling odds, like if you go to the racetrack and you bet on horse number 7 to show, there are certain odds. They give you, 5-2 or 7-1 or whatever the different odds are depending on the horse. That's not odds that we're talking about here. We're talking about probability odds. We're talking about the relationship between this or this not happening. That sort of situation. So the odds gambling, totally different. Probability. Probability can be expressed as a ratio or a fraction. So this one here, it could be favorable to possible. Favorable : possible. Okay, we've got that idea. You could have done that. Now in the previous lessons, whenever we've talked probability, and probably in history, whenever you've talked probability, you've never done it as a ratio, but you could. We're more comfortable looking at favorable over possible. With odds, odds is a ratio or fraction showing favorable to unfavorable, not possible. Possible includes the favorable things and the unfavorable things. Possible is larger. Unfavorable is like part to part. Probability is part to whole, part to everything. So it's favorable to unfavorable. And once again, you could be doing it with a colon, and often you'll see it with a colon, or you could do it as a fraction. Okay? So once you've got those definitions down, here's what it looks like in practice. Okay? From the following group of circles. So what I did is I went here a little while ago and I drew 12 circles. Okay? And there are 12 circles here. 7 of them are colored in. 7 of them are shaded. So I've got 7. Those shaded circles were just done at random. So you've got that. Now if I ask A, okay, what's the probability of randomly selecting a shaded circle? If I'm randomly choosing one of these circles, blindly, just boom, okay? The probability of getting a shaded circle, we know probability, we're comfortable with probability, favorable over possible. There are 7 shaded circles over 12 unshaded circles, and we're done. 7 out of 12. B, what's the probability of randomly selecting an unshaded circle? Well, there are 5 unshaded circles out of 12. Now, where this goes, though, with odds, things are different. Okay? So we had probability, we had probability. What are the odds? So now I know I'm not doing probability. Okay, that is key. What are the odds in favor of randomly selecting a shaded circle? What I'm asking now is how many shaded circles there are. And there are 7 shaded circles if you go back and count. 7 to how many unshaded circles there are. Okay, not to possible, to unshaded. Basically, this happening versus this not happening. 7 to 5. Okay, so 7 to 5. There are 7 shaded, 5 unshaded. 7 to 5, which could be written as a fraction, 7 over 5. But for the purposes of today, I'm just going to try to write them as colons, just to distinguish them. But really, they're the same. Now, I could have also asked, what are the odds against selecting a shaded circle? Now, if the odds against, it's basically the odds that it doesn't happen. Okay? So the odds against this happening, well, there are 5 not shaded circles, and there are 7 shaded circles. So the odds against this happening are 5 to 7. So you've got odds in favor and odds against. Okay? And so those are slightly different things. Now, sometimes the wording can be a little different. What are the odds against randomly selecting an unshaded circle? So the odds against randomly selecting an unshaded circle. Selecting an unshaded circle is this one, 5 to 7. Okay? The odds against that happening, you can flip them, 5 to 7 to 7 to 5. Or you could realize the odds of the unshaded circle not happening is asking for the odds of the shaded circle happening, which is actually question C. So you've got the same thing. Either way, you can either, odds against and you flip it. So 7 to 5 here became 5 to 7 there. And this is the opposite of what I've got written in the margin. Or you just go and, think about what the question's asking. Okay? So going with odds, those are all odds things. Okay? It's part to part versus part to whole. Now with this one here, okay, the odds of selecting the red token from a group of red and blue tokens are 3 to 7. So I know that from here, the odds of getting a red token, that is the red token. There must be 3 red tokens, and there must be 7 not red tokens. Now, if it didn't tell me they were blue, I wouldn't know, but I know they're not red. In this case here, because it says that they're just red and blue, I've got 3 reds, I've got 7 blue. So what are the odds in favor of selecting a blue token? Well, as far as I know, there are 7 blue to 3 red. So the odds in favor of selecting blue are 7 to 3. Okay? Same as the odds in favor of, or the odds against selecting red. Now B, what is the probability of selecting a red token? Well, the probability is favorable over possible. So that word changes everything. Probability is favorable over possible. Favorable, there are 3 red tokens. Possible, how many tokens are there in total? There are 3 red and 7 blue. So there are 10 tokens in total. The probability is 3/10. Okay? The odds and the probability are different. Okay? They are related, but they are different. What are the odds against selecting a red token? Well, if you're not selecting a red token, you're selecting something else. From here, I know there are 3 red tokens, 7 something else's. Now, in this case, they're blue, but there are 7 something else's. So the odds against, selecting a red token. Okay, there are 7 non-reds, 3 reds. It's 7 to 3. Okay. Now, you can just keep going with this sort of idea. Okay. Once you get comfortable with odds and probability, then question D becomes a possibility. The number of tokens is changed so that the probability of selecting a red token has doubled. What are the new odds? So the probability has doubled. So the probability was 3/10. I did that in B. The probability of selecting a red token was 3/10. If it doubled, it is now 6/10. Okay? So if it doubled, there are 6/10. It's a 6/10 probability. Now I've changed the number of circles, so it's not just 3 red tokens, and 7 blue tokens. I've changed the number, but the mathematics, the probability is the same. So if the probability is 6/10 now, what are the new odds? Well, the new odds would be the equivalent of 6 red tokens to 4 blue tokens. Now, it's not saying that I've changed these 3 and 7. I don't have 10 tokens anymore. I have something else. But nonetheless, the odds, the ratio, the relationship between red and blue is the same. So the new odds are 6 to 4, which can be reduced. They would become 3 to 2. Okay? Either way, they're both correct. 3 to 2 is reduced odds. It's just a fraction. But nonetheless, you go from there. So you've got this idea that that has changed. The 3 to 2 didn't appear anywhere. Okay? Continuing on with this, the probability of Margaret winning a game of chance is 0.02, so not very good. Okay? What are the odds in favor of Margaret winning? Well, there's 2/100ths of a chance for her to win. 2/100ths of a chance for her to win. So from there, there's 2 chances for her winning out of the 100. In probability, it would be out of 100. In odds, 2 chances to win, 98 chances to lose. 2 to 98, or 1 to 49. Okay? What are the odds against Margaret winning? Okay? So you look at this. Well, there are 98 non-wins, 2 wins. 98 to 2, or reduced, 49 to 1. So there's not a very good chance of her winning this particular game. Okay? What is the probability? Now keep in mind, probability is something different. What is the probability of not winning the game? Well, the probability of winning the game is 0.02. The Probability of not winning is the complement of the probability of winning, which is going to be 1 minus 0.02, which is going to be 0.98. So the probability that she does not win the game is 0.98, or I could rate 98 over 100, which would be 49 out of 50. I could do all sorts of different things, but nonetheless, there we go. Okay. So odds. It's the same basic idea all the way around. If a group of 7 women and 6 men, including Charlotte, are nominated to serve on a 5-person committee, committees are selected at random. So this has got perms and cons. How many committees are possible? Well, there are 13 people, and I'm selecting or choosing 5. So I'm looking at how many committees are possible. It's 13 choose 5. So 13 choose 5 is 1,287. Okay, so there are 1,287 committees in total. How many committees include Charlotte? Well, that would be Charlotte, and then there are 12 people, and I've got to choose 4 more. So Charlotte is 1 times 12 choose 4, so I figure that out. And that's going to be 495. Okay, so there are 495 committees that include Charlotte, 1,287 that can be made in total. Now once you have those pieces, and I needed perms and cons to get those pieces, now I can do C. What are the odds in favor of Charlotte being selected? Well, the odds in favor of her being selected would be 495, because there's 495 committees that happens, over the number of committees where Charlotte isn't included. That is 1287 minus 495. There are 792 committees where Charlotte isn't selected. It's the idea of odds. Probability would be 495 over 1287. Odds are something different, and I'm going to try to reduce that. 792, see if it reduces. That is a 5 to 8 odds. 5 to 8 odds. Okay? Both would be correct. The 5 to 8 is fully reduced. Okay? What are the odds in favor of the committee concluding exactly 4 women? So how many include 4 women? Well, 4 women would be 7 choose 4. Okay? So if you have your 7 choose 4 times, you've got 1 other man, so 6. So 7 choose 4 times 6. There are 210 committees that have exactly 4 women. Okay? So 210 of them have exactly 4 women. What are the odds in favor of that? 210 to the ones that aren't 4 women. The ones that aren't 4 women are the total, 1287, minus the 210. So there's 1,077 committees that aren't 4 women. Okay? Now, so I could just reduce this, 210 divided by 1077, try to see if that reduces. That becomes 70 to 359. So there's your answer. Okay? So I'm using perms and cons to figure out the parts, figure out what's going on. What are the odds in favor of at least 4 men on the committee? At least 4 men on the committee. So I could have 4 men and 1 woman. 4 men and 1 woman. Or I could have 5 men and no women. Okay? So to get the 4 men is 6 choose 4. And the 1 woman is 7 choose 1. Plus, I could have 6 choose 5. So I'm looking, using perms and cons, how many ways can I make this committee? So I have 7 choose 4, and I'm just doing that. Oops. 7. Okay. 15. This is going to be 105. Plus 6 choose 5. Is going to be 6. So there's going to be 111 committees that would meet these requirements. So 111, odds in favor, 111 to something. I need to figure out what that something is. Well, there are 1287 in total, and 111 of them are what I want, so 1176 is the ones that I don't want. And I try to reduce that, 111 divided by 1176, and that becomes 37 over 392, okay, and so on and so forth. Okay. So you've got odds going through. Now the other thing here is this, F. the odds against Charlotte being selected. Okay. Now the easiest way to do that, I could do this whole calculation, not Charlotte selected, etc., etc. In C, I have a 5 to 8 odds, 5/8 odds that Charlotte is selected. So what are the odds that she's not selected? 8 to 5. I just flip it. Okay. You can't do that with probability, but you can do that with odds. Okay. And so on and so forth. So you've got this sort of idea. These are odds. Okay. They're not terribly hard, but the thing is you have to be comfortable with them. So your homework is at the bottom of the lesson in the notes, page 159, so on and so forth. So please take a look at those, and if you have any questions, just let me know.